Address resolution protocol is to resolve IP address into MAC address. Yeah, it is to resolve IP address into MAC address. Address resolution protocol is to resolve IP address into MAC address. Address resolution protocol. What it resolves? MAC address. From where? It learns the MAC address with the help of IP address. How is this possible? And why you need to know it? Why should I know the MAC address for a device? See, if I'm pinging from A to B, this is the IP address. And for this PC, there are MAC address. Let's just for your easily understanding, I'm just putting AAA. Actually, MAC address size is 148-bit size. MAC address is 48-bit size. Just for your easy understanding, I'm putting CCC. These three devices are connected through a switch. If any packet needs to go from here to here, in OSI layer, I'm focusing on layer 3. In layer 3, what will happen? Source and destination IP address. So if A is pinging B, what will be the source IP address? I want someone to answer. In my class, no quietness. If you are silent, I cannot go next. What is the source address? Source address 10001. You should say which computer, no? What is the destination IP address? Yeah, 10.002. Now, what is the source MAC address? What is the source MAC address? Sir, what I was asking you to consider, kindly mute everyone, it is echoing. So, okay. I was asking you to consider this as a MAC address. It is good that I'm asking you a question. If I simply keep on teaching and you don't really understand, it's of no use. I asked you what is the source MAC address and you are saying 10.0.0.3. Why will 3 come into picture? When I am communicating between A to B, what is our scenario? A communicates to B. This is A's source address. A is the source, so A's address is source. B is the destination, so B's address is destination given here. Now, what is the source MAC address? I asked. What is the source MAC address? Why you are saying 10.0.0.3? Pay attention to the class. AAA. And destination MAC address is actually DDD, but this PC do not know about the destination's MAC address. Why? This PC will not know about destination MAC address. Why? Because we don't mention MAC address. See, when I'm pinging here, Whose IP address is this? B computer's IP. I'm only mentioning the IP address. That's how it knows the destination IP. While pinging, am I mentioning any MAC address? No. We don't use MAC address to communicate. We use only IP address to communicate. But in the OSI layer, all 7 layers are important. In layer 2, the MAC address is important. If you don't put the MAC address here, the packet cannot be valid. The packet will not even go out of this computer A. It won't even go out. See, all the 7 layers of OSS should be fully updated. Only then the packet will be valid packet and the packet can go out. So for a packet to be a valid packet, for the packet to go out, you need layer 3 source destination, layer 2 source destination properly in place. But how can computer A know about the MAC address of computer B? That is where ARP comes into picture. See, while pinging, you are giving the IP address, no? If you give the IP address, our protocol can learn, discover, resolve the MAC address. So if I say find the MAC address of 10.0.0.2, our protocol can learn the MAC address. Our protocol can learn the MAC address. D. How is that possible? How can our protocol learn this? See, so far what I was teaching you is, without the destination MAC address, you cannot send the packet. If you want to send the packet to computer B, only IP address alone is not enough. You need also MAC address. Your computer needs MAC address. IP address we give while sending a traffic. For example, here when I ping, I'm sending ICMP traffics. When I say ping, I'm sending ICMP traffics. I'm providing the destination IP address. No, 10.0.0.2 is what? Destination IP address. But the MAC address, we don't give. And how the ping will be possible? The MAC address need to be learned. To learn the MAC address, this protocol will help you. Actually, you don't need to go and enable this protocol. These are automatic, but we are just learning how it is automatically working. So when you try to generate some traffic between A and B, when you try to ping, what really happens is it generates a traffic between A and B. That is what ping. Ping is just checking whether B is available or not. That is what ping. So you might have heard people saying, okay, I'll ping you at 5 o'clock. What does that mean? I'll call and check with you at 5 o'clock. That's the meaning of pinging. I'll call and check you. Check your availability. That is what pinging means. So when I say ping 10.0.0.2, A is trying to send a traffic to B, but without knowing the MAC address of B, it cannot send traffic. See, if I know Kiran, can I talk to Kiran? No. I also need his phone number. I cannot talk to Kiran without knowing his phone number. Knowing IP address is like just knowing name 10002. I know the name of Kiran. But I do not know the phone number, then how will I talk? I need to know the name, I also need to know the phone number. So what will I do if I want to know his phone number? I will ask all my students, hey, do anyone know Kiran? And Kiran is also in the group, in my student list. He says, sir, it's me, Kiran. This is my phone number. So he's responding me from his phone number. It's me. Then I now know his phone number. Exactly the same thing is what ARP will do. To learn the MAC address, it will send the packet out first, an ARP request packet. What is the ARP request packet? It's a layer 2 broadcast packet. I told you on the other day what is broadcast? Sending to all. That is broadcast. Layer 2 means what? MAC address based broadcast. For example, this computer will send a broadcast saying source address is A, destination address is how many times F I have written? Can someone tell me? How many times F I have written? Count and tell. Unmute and tell. How many F? Sorry? Very good. This is what called as layer 2 MAC address, layer 2 broadcast address. 12 times F, if you put that is what address which is going to take your request to everyone, that is called broadcast, to everyone. If you want to send a packet in a layer 2 level, you need to use this address. ARP uses this address. You no need to say ARP get up, why are you sleeping, use this address. No, you don't need to say that. Whenever you try to reach someone with the help of IP address, the computer will check the ARP table. For example, I'll show you in my computer. Command prompt ARP, ARP -A. You see how many MAC addresses, the IP address and the MAC address, the IP address of the device and the MAC address. So my computer has got the ARP table. So only the IP address is not sufficient to ping with someone. You need what? MAC address. One more time, let me show you. ARP space -A. Do you see here? 12 time F. It's a layer 2 broadcast address. This is layer 3 broadcast address. 255.255.255.255. And this is layer 2 broadcast address. So what ARP will do, it will send an ARP request. Inside the ARP request, it will ask like who is 10.0.0.2. Who is 10.0.0.2? Because it's a broadcast, it will go to C, it will also go to B. And B will respond because B is 10002. B will say ARP reply. B will send an ARP reply saying, it's me, 10002. To whom it is replying, 10001. This is source, this is destination. What's the source MAC address? DDD. What is the destination MAC address? A. So this will be the reply packet. B is sending a reply packet to A. Now A knows the MAC address of B. So it will put MAC address of B here, DDD, and now the ping will be successful. So what you have learned now is ARP resolves IP address into MAC address. ARP will resolve IP address into MAC address. How it resolves? Can someone answer? How ARP resolves IP address into MAC address? I just finished teaching ARP and you are not answering. How ARP resolves IP address into MAC address? By sending a layer 2 broadcast. By sending a layer 2 broadcast, ARP resolves IP address into MAC address. How can you say it in another word? By sending an ARP request to a layer 2 broadcast address 12 times F, the ARP request will go to everyone asking who is 10002. Computer C will not respond it because computer C is not 10002. Computer B will respond saying, it is me, my MAC address is DDD. That is how A learns the MAC address of computer B. Is this clear? I don't know why you are long.